Objective 6 is to use the discriminant to determine the number and types of solutions that exist in a quadratic equation. So up until now, you've actually used the quadratic formula to solve quadratic equations, but this skill is now to be able to just look at the discriminant and be able to tell how many and what type of solutions will exist based off the discriminant. Alright, so to begin, what is the discriminant? The discriminant exists underneath the radical of the quadratic formula. So it is the number you get when you simplify the negative b, or I'm sorry, not negative, just b squared minus 4ac part of the quadratic formula. So whatever number you get, that is considered to be the discriminant, and that'll tell you how many types of solutions and what types of solutions you will have. So let's do example 1. If I was going to find the discriminant of example 1, I would first have to put it into standard order, or standard form. So we've been working on that. In order to do that, I need to move the two things on the right side of the equation over to the left. In this case, it's my b term of plus 8x, so I'm going to have to subtract 8x to this side. And also my c term, which is a negative 4, so I'm going to have to add 4 to both sides. So that cancels it out on the right-hand side, so I know it'll equal 0. So in standard form, it's highest power to lowest power, so it's 4x squared minus 8x now, plus 4 equals 0. That's step 1. Step 2, it's the same thing. It's the beginning part of the steps necessary to solve using the quadratic formula. Step 2 is to identify the a, b, and c. A equals 4, b equals negative 8, and c equals 4 as well. Step 3 is to insert them into the quadratic formula. So it's opposite of b. In this case, my b is a negative 8, so it's going to be opposite that, which is positive 8 plus or minus the square root of b squared, so negative 8 squared minus 4 times my a, which is 4, times my c, which is 4. All over 2 times a, which is 4. That's step 3. Step 4 then, it gets into this discriminant, and this is the math that you're going to have to do to solve the problems that you're going to practice in regards to the discriminant. So in this case, this reduces down to, and this will be step 4. This is the final step of this process. Underneath the radical, this will reduce down to 0. So negative 8 squared minus 4 times 4 times 4 equals 0. So now, my final step, step 4, is I have the square root of 0. In this case then, I would always, when you're practicing this, reference this chart down here. So I'm going to write that this example has the square root of 0 as the discriminant. Equals d. D for discriminant. And so when d, these are the situations that occur. The value of the discriminant right here gives you the type and number of roots or solutions, and then the sample of a graph that you would see. So you need to reference this chart when you're practicing these problems. So in this case, we have discovered this situation. Our d equals 0 underneath the radical right here. Our d equals 0. So when our d equals 0, to finalize this then, the discriminant, and to answer this question, to answer the following questions, I need to know that d equals 0, and that means that you will have one real rational root. One real rational root. And technically that it is a double root at that point, meaning that it bounces off that point and goes back up the same. So example, x equals 5, and this is a graph version of that. it comes down at 5, it bounces back up and goes the same spot. So technically there's two solutions that exist there, they're just both 5, so it is a double root. So in this case, this would satisfy my answer for this example. This is all I'm looking for. So from step 4, I can know that my discriminant simplified to 0, and so because the discriminant is 0, I have one real rational root, and I know that it's a double root at that point. You need to be able to get to this to solve this correctly, these types of problems for finding the discriminant. Now, to finish this video, let's look at the other examples that will occur when you're doing these problems. You might arrive at a discriminant that's greater than 0. So if the value of the discriminant is greater than 0, right here, so for example, you might have underneath the radical, when you simplify it, the square root of 49. So this discriminant, 49, is greater than 0 and it's a perfect square, meaning that you can take the square root and get a whole number there. You can automatically go to this, the type and number of roots. You will have two real rational roots. Example, so eventually you could get x equal 2 and x equal -4. This is the situation where you know that it will break down to whole numbers, and you will have two whole number answers at the end of the quadratic formula. And the example of a graph, I know it will intercept the x-axis at whole numbers. X-axis highlighted in blue, and it'll intercept it at whole numbers. In this case, it could be 2 and 4. Another situation is d could still be greater than 0, but it's not a perfect square. So let's say the square root of 90. 90, if the discriminant was 90, is not a perfect square, meaning it breaks down. You have to simplify it into simple radical form, and that means that it will still have two real solutions, but instead of being rational or whole numbers, they're going to be irrational. And you'll have answers like x equals the square root of 13 and negative square root of 13. So this would tell you that if this is the case, your final answer when solving the quadratic formula is that you're going to have a radical in your answer somewhere. It'll still hit the x-axis, it just won't hit the x-axis at whole numbers. And so this could technically be a similar example of a graph. It would just go, it wouldn't hit a hash mark at a whole number. And then finally, the other situation that occurs is d would be less than 0. Let's use the example of square root of -50, where our discriminant then is -50. In this case, you would have two complex roots, or I've said two imaginary roots, or two imaginary solutions, that type of thing. Now, the final answer of your quadratic formula, if your discriminant is less than 0 or negative, you will be left with what's called a complex conjugate. And I'm going to talk about this in the next lesson on operations on complex numbers. Complex conjugate just means it'll show itself as a whole number, plus or minus, and imaginary, just like that. So those are the four situations that occur. And finally, with the negative, square root of a negative, we've talked about this before, but this graph shows you that imaginary solutions do not cross the x-axis. They still exist, but they don't hit the x-axis, so they are not x-intercepts. And again, these are the four situations that occur. So as you're working through your practice problems for this objective, you need to reference this graph the entire time, or this chart the entire time, to help you say, to get to this point. I know that, oh, d is 0. That tells me there's one real rational root up here. Or d is square root of, or d is 49, a perfect square. So that tells me there's two real rational roots. I need to see your answer like I squared right here, something that looks like that.